thank you all for being here today. I'm going to talk about an episode of Mississippi River water exports last summer in 2014, and all this work started with a conversation I had with my friend Felix, who's here in the audience, after he got back from the research cruise for the Poulet Ridge project after August 2014. And he told me that during the cruise they found something very weird, a very intense drop in salinity observed in the Poulet Ridge area, which is south of the West Florida shelf. And they found that the salinity dropped from 35 to 32. And he told me that scuba diving through it, it was obvious the difference in the water masses between the upper 10 meters and below it. So it triggered my interest, and I asked whether I could look at the data that they measured on board the Welcome Smith. And this is the sea surface salinity measured on board on the way from Miami down to Poulet Ridge. And we see the salinity, which is at its usual value, so towards 35, 36. And then suddenly, after August 18, we see a major drop in salinity that goes to 33, 32. And not only in the Poulet Ridge area, but all the way along the Florida Reef Tract. And this is the time series of the onboard salinity. So we see the very intense drop on August 18. And despite some spikes in salinity in the following days, it stays in very low values for the rest of the cruise. And so such salinity drops have been observed in the Florida Strait in the past, and they have been associated with the episodes of Mississippi River water export. And especially the main event, the first event to be referenced was in summer 1993, and it was described by Peter Horner and authors. And it was following a large Mississippi River flood, and water masses with salinity of below 32 were advected towards the Florida Strait and further down in the Atlantic Ocean. Other such events happened after that. In 2004, was referenced metropolitan Mississippi River waters. It was described by Uestal and Chinan Koafalu, with the signature in ocean color. But this one was not as intense as the 1993 one. And going back in 2014, the vertical section of salinity measured during the cruise at 3 different dates showed that the layer of low salinity waters is 10 to 20 meters deep, which is comparable to the 1993 episode. So this is a very intense episode with a major drop and on quite thick layer of water. But on the opposite of 1993, 2014 is not a year of Mississippi River flood conditions. This is the river discharge values. So in black is climatology, and in red is the values for 2014. And we see that it nicely follows climatology, and it's far from the values that one can see in typical flood conditions with 2011 values. So this makes the event of 2014 a unique event because there is no flood, but there is a major signal down the Florida Strait. So the features that favor such long-distance exports, the number one is the extended loop current in the Gulf of Mexico. So this is a figure again taken from Hoffner et al. And this is a map, of the temperature from early August, and we see the gradient of temperature associated with the extended current here. And superimposed on that is the trajectory of the surface drifter that was in the Mississippi Delta area by late August and was advected down to the Florida Strait along the loop current. And it arrived around September 10, which is about the date that the low salinity waters were observed in that area. Other factors favor the offshore transport of Mississippi River waters. They are more local in the Mississippi Delta area. And those are first typically westerly or southwesterly winds in the Mississippi Delta area. They favor the advection of waters towards the east, and they oppose the natural advection flow of the river, which is towards the Louisiana and Texas shelf to the west. Also, the eddy field in the northern Gulf can favor the transfer, the advection of river waters offshore, especially when the loop current is extended or when it sheds the loop current eddy and anti-cyclonic eddy, it's able to entrain waters with it. And also cyclonic eddies, if they are paired with a loop current anti-cyclonic eddy, they can also participate in such exports. In addition to that, the thermal stratification favors the spreading of low salinity waters at the surface. This is a map from the event of 2011. So we see, this is an image in chlorophyll A, and we see the signature of Mississippi River waters extending down towards the Florida Strait, even though there were no measurements, in-situ measurements to quantify the drop in salinity, but we see clearly on this image that such export took place, and it was favored at the time. We see here the anti-cyclonic current eddy here, and associated with a smaller cyclone here, and both together they favor the offshore export of Mississippi River water. So, going back to the 2014 episode, we wondered what are the conditions that favor the observed export of Mississippi River water. We want to know the processes that control the pathways of the Mississippi River water. And also locally in the Florida Strait, we want to know what processes triggered the transfer this time from the offshore, the waters that sit offshore the shelf onto the shelf where they were actually observed. To do that, we set up a model simulation of the Gulf of Mexico, which uses data assimilation. It is based on the HICOM model with a 1/50th degree resolution, about 2 kilometers. This is the model domain with the symmetry, with the deep part inside in the middle of the Gulf, surrounded by continental shelf, the narrow shelf in the Mississippi Delta, and the wide shelf, especially the West Florida shelf here towards the Florida Strait. The model is forced with the Navy atmospheric model, NAVGEM, half-degree resolution. The initial conditions are taken from a pre-running simulation which uses the same configuration that has been run for 4 years, and the model is nested in the operational global HICOM, which has a resolution of 1/12 degrees. This simulation has improved river physics based on the work by Schiller and Guarfano in 2010, and it has realistic river data to force a realistic discharge of the river. And finally, it has data assimilation. It's performed daily using a sequential assimilation filter based on Kalman filtering theory. It's an ensemble optimal interpolation, and we assimilate a long track sea surface height from the altimetric satellite and the sea surface temperature. So, I'm going to describe the episode based on maps of sea surface salinity in colors from the model simulation, and I added the contours of the sea surface height, and the solid lines are associated with values above average, and the dashed lines are values below average, and closed contours, continuous ones are mostly associated with anti-cyclonic circulation of the loop current, and the dashed ones are more associated with cyclonic eddies, such as here. And I also added the contour of the loop current in the delta. So we see that in early June, the low salinity waters are confined in the northwest of the area, so in the Mississippi Delta area. And the loop current has, for now, a limited extension. Then, in mid-June, we see a quite rapid spread of low salinity waters first along the coast. And then, later in June, this initial branch is extending eastward, and it's followed by a secondary branch just east of the Mississippi Delta. And at the same time, we can see that the loop current forms an anti-cyclonic loop current eddy that just detaches from the main current. So these first eastward export branches are supported by the wind. So this is these are two-hourly wind vectors from the Mississippi Delta area, and we see that the wind is dominantly from the southwest, which favors this eastward transport through Ekman transport. Now, in early July, the initial branch keeps extending eastward and then southward along the edge of the West Florida shelf here, while the secondary branch keeps extending to the east. And in mid-July, we see that part of the secondary branch is entrained around the loop current eddy, which has migrated quite north and which will now be able to interact with the main plume to drive it to the east. And towards the end of July, the initial branch keeps extending southward here along the edge of the West Florida shelf, and the secondary one keeps extending to the east and being fed by low salinity waters from the delta itself. And in late July, this continues on the same with the same pattern, except that the first branch tends to slow down, while the secondary branch, which becomes the main branch of export at that time, keeps extending eastward towards the West Florida shelf. And again in July, the winds are dominantly from the west, and they keep favoring this export of low salinity waters in the Mississippi Delta area, which feeds the main branch. In early August, so the main branch keeps extending towards the West Florida shelf, and part of it is entrained around the loop current eddy. And this stops by mid-August when the current reattaches to the loop current eddy, and that favors the entrainment along the loop current itself towards the Florida Strait. And by late August, if the low salinity waters have started to reach the strait and close to the Mississippi Delta, we see that still there is entrainment of very fresh waters from the delta, so that it's feeding the main branch. So this again is favored by the winds, which remain from the west throughout August until August 25th. And around that date, there's an intense reverse in the wind that is this time opposing the spread of the low salinity waters, and it has a major impact on the main plume, because here on September 1st, we see that the signal in salinity has decreased a lot in the Mississippi Delta area and close to it. And this is even more pronounced like 1 week later, where we see that the low salinity waters have retracted to their initial situation close to the Mississippi Delta, and on the shelf, and this interrupts the main branch, and it marks the end of the export season. So if we now focus in the Florida Strait, so this is a zoom from the model on the Florida Strait this time, and so this is again the surface salinity, and I superimpose arrows for the surface current, and we see that the low salinity waters arrive in the strait between August 10 and 19, and we see the signature of the Florida current, which is the loop current when it reaches the Florida Strait. And also more strikingly, we see on August 19 the presence of a cyclonic loop current front of eddy, which is able to entrain waters and push them towards the shelf where they were observed in that 83, 84 degree west. That's where the Walton Smith was. Later on, so the river plume keeps, the Mississippi River water keeps being entrained to the east inside the strait, and we see a northward current that is able to entrain some of the water across the shelf break towards the Florida Keys here. And by early September, this overflow of low salinity waters is more marked, and it has reached the low salinity waters that cross the Florida Keys into the Florida Bay, and also more to the west, we see a big marked signal of low salinity waters going over the shelf. But in the simulation, we see that the salinity of the plume is about 35 at the lowest, and it's different from the observed values, which were more marked. The salinity dropped reached 32, and we reached here about 35. So that's one limitation. Now, if we look at the wind, this is the wind vectors in the area. We see that the winds tend to are mostly from the east this time as opposed to the Mississippi Delta area. And they tend to intensify around mid-August. And this, especially, so we can see here on August 26th, the winds are from the northeast and they favor a northwestward eastern transport, which is consistent with what we saw with the current and the spreading of the low salinity waters. And early September, the winds in the straits are directly from the east and they favor a northward advection, which is consistent with the spreading of the low salinity waters. So this illustrates that both the wind and the loop current frontal eddy favor the onshore transport of the low salinity waters from offshore the Florida Straits onto the shelf. Now if we compare this simulation with observations, so I'm using 3D composites of ocean color index, and going back to June at the initial stage of the event, we see in the observations the spreading of the Mississippi River waters, which are associated with intense flow fields. We see that they spread to the east, so that the model is consistent with that. In July, we see that the initial branch keeps extending eastward and then southward along the West Florida shelf. And later in July, the secondary branch peaks. And again, this is and again, yeah, this is something that we've seen in the simulation. In August, so the main branch is clearly seen here, and we see that it extends far south along the West Florida shelf, and actually it extends further south than what we saw in the simulation. And after the loop current reattaches by mid-August, we see that it's able to entrain part of the main branch to the south in the deep Gulf of Mexico towards the Florida Straits. And we also noticed here the signature of the loop current frontal eddy that I mentioned in the zoom of the Florida Straits. And this is it has a clear impact on the advection of the waters that's in the observation. And yeah, going to early September, we see the pronounced decrease in the intensity of the signature of the Mississippi River waters, and the fact that the river waters retract to the Mississippi Delta area and to the shelf, which is something that is well represented in the model. So overall, there's a good agreement between the simulation and the observation, and yeah, the observed ocean color images. So as in the sequence of events that led to the export of the river waters. Now, if we compare our model simulation with the Aviso 3D cystophosphide data, so the model assimilates a long track altimetry, so we expect a good agreement, and we're happy we have it. So especially the loop current dynamics is well represented. The dates of the loop current detachments and reattachments are well described in the model. If we look more into the details, we saw that the main branch was adapted eastward during most of July and August, and we see in cystophosphide that it is associated with the loop current anticyclonic eddy that has detached from the loop current, and we see that it has a peculiar extension to the east. That is, we see here with this feature here that favors in addition to the wind, the advection of the Mississippi River waters. And this is something that is initially well represented in the model with this eastward extension. It matched really well with observations in the model. And if we look further in July and August, we see that in both the model and observations, we keep having this eastward extension that brings the water towards the east and the west Florida shelf. But what we see in the observation is that this pattern has a southward signature in July and August that we cannot really reproduce in the model. And that explains why we have limited southward extension in the river plume in the model compared to observation. Because in the model, it will be a trend offshore around here and here between late July and early August, whereas it is affected further south in the observation. So to summarize the event, we saw that in June and July, an initial eastward extension, first along the coast and then directly east of the Mississippi Delta, so this entrainment was supported by the dominant westerly winds and the unusual extension of loop current anticyclonic eddy. In July and August, the main branch reached the West Florida shelf and followed the southward path, whereas the main branch is still fed with low salinity waters in the Delta area. And by mid-August, the loop current reattaches to the loop current eddy and is able to entrain the Mississippi River waters in the Florida Strait. So this is a peculiar pathway because first the Mississippi River waters are entrained to the east and then to the south away from the loop current, and it's only along the West Florida shelf and quite south actually in the observations that the main branch reaches the offshore Gulf and is entrained towards the Florida Strait, and that's very peculiar because usually the Mississippi River waters are entrained offshore in the Mississippi Delta area, either through the winds or through the eddy field, and this is not the case here. So this is another aspect that makes this event quite unique. And here in the Florida Strait, as I mentioned before, it's a loop current frontal eddy and associated with easterly and northeasterly winds that favor the onshore advection of low salinity waters on the shelf where they were observed. And the GOM HICOM 150th degree gives a realistic representation of this sequence, despite some limitations. First, the limited southward extension of the branch along the West Florida shelf, and the 2-week signature of the Mississippi River waters in the strait. But besides that, I think we have a realistic representation of the event. And we want to have a more quantitative estimate of the performance of the model, so we compare it with the results from the global HICOM simulation, which is one of the considered the most robust operational simulation to date. And also we want to compare with another HICOM simulation performed in the Gulf of Mexico at 125th degree resolution. So this one is a bit different from ours because it has climatological forces at the boundaries and for river forcing. And it has also relaxation of the system salinity. Both simulations use the ENCODA assimilation scheme, which differs from the one that we use. And this is the root mean square error in system height. So in blue is the performance of our Gulf of Mexico 125th degree, and in black is the 125th Gulf HICOM from NRL, and in orange is the global HICOM. And so they are compared with the Abydos graded data. So those data represent have a nice representation of the large scale and the large mesoscale. And we see that the 150th Gulf HICOM performs better than the other two simulations because the RMS error is about, well, actually around 4.5, I think. I don't know, it's 4 something centimeters, about 7 centimeters for the other two simulations. So it means that our model is able to represent the large scale and the large mesoscale in a very satisfying way. And in particular, it means that the fronts and the mesoscale features will be quite decent. And we also compared our model with the salinity data set from the 2 satellites, Aquarius and SMOS. So Aquarius is the NASA satellite that has been launched in 2011, I think. And SMOS is the satellite from the European Space Agency. So they don't give as fine resolution data as altimetry. So I think Aquarius is 1 degree and Smooth 0.5 degrees. And I'm using weekly data, otherwise it's too noisy and too patchy. So this is, so the dashed line is for Aquarius data. It's a comparison with Aquarius data and cellular comparison with Smooth. And we see that the gum icon and 150 degrees in blue has generally low value, but tends to increase in the summer due to the 2-week signature of the Mississippi River water. But it performs much better than the NRA 125th gum icon, especially in spring. So we find that the performance of the model is quite satisfying. So yeah, those results about this modeling study were just submitted to Ocean Dynamics, the work I've done with you. And on a more broader perspective, I want to talk about the 150th gum HICOM simulation. In respect to the recommendation from the Goday, Coastal Ocean, and Chef testing about top-down scaling and regional analysis products. Namely, it's the use of operational global Goday products for nesting at the boundaries and the use of realistic high-frequency forcing for the atmosphere, and also here for river forcing. And this simulation was able to reproduce the 2014 export episode. And yeah, the use of both the assimilative model and setting up the data assimilative model and using and comparing with observations proves very useful for identifying the key aspects of this export episode, especially the forcing of the eddy field and like this peculiar extension of the loop current the loop current anti-cyclonic eddy is something that we fought for having well, and because we realized that it was something that really mattered to have the event well represented. And this simulation is an asset for the joint NOAA, OML, UN, Rasmus, Ocean Modeling, OSI, and Center group, which is led by Billy Kouafalu and George Halliwell. It's a good tool for studying at high resolution the typical regional processes, and in particular cross-shelf exchanges that I've shown today. And it is also a good asset for studying the impact of observation networks that can constrain this type of processes through OSI studies. And this is what we will do in the NOAA research project that just started. And currently, this simulation is in transition towards being implemented in near real time for demonstration purposes. So now moving on to more present days, I realized that there was also an event of Mississippi River water export this year in 2015, looking at the observations. And so this is plotted a map, and we see late June that the river waters are well constrained on the shelf, like they usually are. But then by late July, we see that they extend quite clearly offshore, and we see also a branch that goes to the south and towards the strait. And we have nicer images in early August, and we see this time the initial branch that was going to the West Florida shelf, a bit like the 2014 event, has a bit decreased in early August, but there's a main branch following the loop current here that is very intense, and still we see signature of high trophy water reaching the strait. And later in August, we see a large patch of such water stuck inside a frontal cyclonic eddy this time. And later on, the loop current detaches and then reattaches, and there are some events of, patches of high chlorophyll waters that reach the Florida Strait also later on. And if we look at what we have in this event is also favored by westerly winds in the Mississippi Delta area from about mid-July to mid-August. And also it's supported by this time above average discharge values for the Mississippi River itself. And especially in July and August, it's about twice the values that are usually observed, so that also triggers such events. And so the fact that the waters are entrained mostly along the loop current and this event is associated with a large discharge makes it probably a more classical case. And in the model simulation, we see that late June we have constrained extension of the low salinity waters on the shelf. But then between late June and late July, we see that the waters have extended quite far because there is this radar trace here, and in the same direction as was observed. And again, moving from late July to early August, the main branch is more to the south and along the loop current, which is exactly what was observed. And later on, we see this large patch of low salinity waters taken through this frontal cyclonic eddy, exactly like in the observation. So, yeah, there is no in situ data or no satellite data for salinity, so that we can compare the amount of the actual salinity drop during that event. But I think that the simulation performs well, and it's very encouraging. And with this, I thank you all. I have two questions. One, I noticed that it didn't look like the 125th model did any better than the 112. You mean the height? Yeah, it's very similar. So I would have expected. I thought they were going to, come out with some sort of gradient there as you got higher and higher resolution, but made no difference, it appeared. And the second thing I noticed was, is that the same explanation? The fact that you didn't pick up that southern extension, does that explain why the salinity didn't drop quite as much? Yeah, we think that is the exact location. Even though we perform statistically better than other assimilative simulations, having the exact mesoscale field with the right location and the right intensity and amplitude, I think it's key to having it well forced. And we've had, I don't know, 15, 20 simulations trying to fine-tune the data simulation and the forcing, and we've had huge progress, but not to the point of having the right numbers matching. So, and there are still progress to do, but I think we have a good description of it.
About the NRA models, there is another issue though. The 125 is better resolution. That does not make it necessarily a better model because the global has all the stipulations. The 126 is not nested in the global. It uses climatological boundary conditions, so it needs some realism. And the big step is this model is the very first regional one in the area that is actually nested in global cycles.
Yeah.
The branch that moves southward along the west Florida shelf, how much does that water train to the Florida Keys into the Florida Strait, and is that possibly underpredicted?
Yes, underpredicted because it doesn't extend as far south, so it slows down and then it can train offshore. So that has an impact on also on the timing of the event in the model simulation because we have the main signature of the salinity drop in the model simulation is a few days later than what was observed. So I think that has to do with the southward extension because it goes on sorry. Here, so this is early August, and this is I didn't put the observation map from late July, but between late July and early August, this extension here is really quick, and that we don't have, and I think the waters that are entrained here, that's the waters that reach the West Florida shelf.
Okay, and how about the branches to right along the Florida coast? The West Florida.
Here?
Yes. Is there any exchange to the Keys from that branch?
No. No, they'll stay here. It's local.
Okay.
Local along the state. Yeah. Anything?
Matthieu, I was wondering if in longer term simulations or in analysis of the chlorophyll data from long term, if there's there's an indication that the frequency of these events, it seems like they don't happen every year, right?
No.
So is there maybe some long-term modulation of how often these events happen?
Not that I know, because, well, there's 1993 events, 2004 events, and 2011, although 2011 we don't have in situ data, so we don't know how intense that was. So I think, yeah, 3 events, now 4, maybe 5, I think it's too few to find a trend in that. But yeah, obviously that's...
Maybe the favorable winds.
Yeah, typically the wind is part of the game, and the extended loop current, because it's either the loop current itself or loop current anticyclonic eddy that is also playing a role in all those cases. So I think the two really support these events. And although loop current doesn't really have seasonal trend, maybe the winds there, if there's a change in the typical winds, then that might be interesting to see that.
That's one more. I noticed that the labels in your model reanalysis. So
Yeah.
does that mean that you have some data simulation after the fact? Like after the simulation is finished, you simulate some metrics?
No, I mean that because we use, especially for the 2014 event, we use the delayed time, typically the delayed time altimetry data, which are of better quality, and also the simulations from NRL, either the global or the Gulf of Mexico. They use data on the fly, and not all the data are there. So that's also why we perform better, because we have all the observations with better quality. But for the 2015 case that I showed that the model was doing well, we have the near real-time altimetry data. So we have maybe more data because sometimes the altimetry data has some delay, so not all of them are available for the operational groups. But the data we have are not delayed time, not such good quality, and we still do well. So I think it's good.
Have you ever considered quantifying the connectivity between like the mouth of the Mississippi and the Florida Strait by releasing simulated particles in the model and then seeing how quickly and what fraction are affected? Well, you could actually create a time series.
We could totally do that. Since the values of the salinity drop are far from matching, I mean, the intensity of the drop didn't match. I don't think that quantifying the export would be very relevant in this case, but if the 2015 proves to be to better match observations, that would be something to do, either through quantifying the fresh waters or by releasing particles. Yes, that is definitely something we can do.
So for the years in between the events you reported here, so the data don't, if you look at data, you don't see any evidence of these events occurring, or you just, like, have you looked into the intervening years, or is it clear that there haven't been events?
So the data set that I used for ocean color, it starts in 2010, 2011. So there was even 2011, but I don't think that there was any even in 12 or 13. But yeah, it's short data set. So, but that's then the more it goes, and that's the data set that I look every day because it's fascinating. Well, this is large scale event, but also it shows very fine scale processes such as small eddies and around in the Florida Keys. Yeah, there are very cool stuff going on there, and I totally encourage people to look at these data sets because it's fascinating. Any more questions? On the phone, are there any questions? No. All right. Well, thank you. Yeah. Thanks. Well, you knew the story already.
Oh, well, I already read the paper, right?
Yeah?
Okay.
Yeah. There's also more recent data in the 2015 that OCED is still doing it. So you can,
Oh, yeah, well, that's new for this.
Yeah, right. So, it's very interesting.
Do you know, I'm not fully research, but
Yeah.
did you just
captured right at the right moment, or was the characteristics of the data set based on the fact that you were closer inshore on the way down, trying to, because it uses a countercurrent to run,
Yeah.
you know, and so maybe the higher, the lower salinity, higher chlorophyll was there, but offshore, and then they hit it on the way back. Did you notice if the tracks were right or functional? It just seems really weird that like halfway in the middle, you got it put out there.
No, it's also where we studied because most of the time